All right, we're on Module 9. This is all about triangle similarity, and we are on day 1. So we are looking at our learning target for this is I can identify similar objects with a focus on triangles for the whole module. But our first day is going to be I can find this top one on our success criteria. I can find scale factors from one to another object. So that's what we're going to look at to start with that. So our whole thing here, again, is finding scale factors and know what we're looking for with that as well. So what some of these vocab words are, okay? So we're going to look here first off, scale factors. Anytime we have a scale factor, we're going to call that a dilation. So whenever a shape is getting either bigger or smaller, we call that again a dilation. Whenever it is again changing, you can think of it as when it's changing sizes, is what you could for that. Okay? And when that size is bigger, we call that enlargement. So that's bigger than the original one. And when it's smaller, we call that a reduction. So an enlargement and a reduction are dilations. The dilation is just the changing of the size. The scale factor is the actual number that we multiply by. So the number, again, that's going to change it and make it bigger, like 2 times bigger, or it's 5 times bigger, or it's half of what it is. So, and then our center of dilation is if we're on a grid, like a coordinate plane, we're going to have a point at where we're dilating at. Everything we're doing today is going to be from the origin, from 0, 0. So my center of dilation for this stuff today, again, is everything from 0 to 0. This is just to give you some base if you move forward and start dilating things from a different point instead. So, okay, so again, I told you our learning target was to identify scale factors and be able to apply them as well. So let's start with this. So let's look at, we're going to use the letter K to denote when we're dealing with a scale factor. And what I want you to do is be able to look at those numbers that we have and know whether it's an enlargement or a reduction. So it reduces when K is less than 1. It enlarges when K is greater than 1. The one thing about reduction, though, is it cannot be lower than 0, though. So K has to be bigger than 0, and it has to be less than 1. Notice we're not equal to 1 on either one of these, so we don't worry about that. So anything bigger than 1 enlarges, anything less than 1 or greater than 0 reduces. So if I look at this K equals 3, 3 is bigger than 1, so this enlarges. Okay? Look at this, K equals 1/3. This is going to reduce. So I should be able to tell right off the bat that way. This is 3/2. 3/2 is bigger than 1. That's why I don't ever say fraction. 3/2 is bigger. So this is going to enlarge as well. And then 0.67 is less than 1, so this is reduce. So that's that first skill you guys need to do. Be able to just look at it and be able to tell when or whether that number is going to enlarge or reduce the original object from that dilation. Next thing I want you guys to be able to do is look at two figures and determine whether or not it's an enlargement or reduction. You should be able to do that just by sight and then find that scale factor. Okay, so we're going to look from this one here. This is going from orange to blue. So orange to blue. Notice how I have these little prime numbers on here. That always is the after image. So no primes, like just A is pre-image, and then we've got our image after with the primes on it. But it also tells us we're going from orange to blue as well. So this is getting bigger. So we are enlarging here. Okay. Oops. So it's an enlargement. And then to find my scale factor, I can either pick a side or I can pick a point. Either way from this. But I have to have a corresponding side or a corresponding point. What I mean by that is if I pick point A, I have to have that corresponding point of point A prime. If I pick the side length B to C, then I have to have the corresponding side B prime to C prime. So I have to do one or the other. And then once I pick those corresponding points, all I'm going to do is go new divided by old. Okay? So if I'm looking at a point, this point A here, it's at 0, 1. And the new point is at 0, 4. So I'm going to take the new, and I do not ever want to deal with zeros. So I'm going to take the new, which is 4, and divide it by 1 in this case. And it should work both as long as you don't have any zeros. So this would be 4 over 1, which again just simplifies to a scale factor of 4. Okay, if you did a side length, let's say we went from B to C, that side length is 2. This side length is 8. So if it was a side length, I'd go 8 divided by 2, which again simplifies to 4, and it should give you the exact same thing. Okay, let's look at this one. So we're going from green to purple. So this is reducing. So this would be a reduction. And then to find the scale factor, again, just pick a point or a side length. Whenever we got slants, I never use those. You can use straight side lengths, or you just use a point. Again, this point is at 2. This point is at 8. And it's always new divided by old. Okay, so this would be 2 over 8, which would simplify to 1/4. Again, if you used a side length, we could use a side length over here. You'd actually probably want to use this RS, which is 2 wide, and this is 8 wide. You get the same thing, 2 divided by 8. Okay? All right, keep moving here. The other thing we want to do is be able to draw the shape given the scale factor. Okay, so if I have this one here, I'm going to draw this shape with this scale factor. So this should be getting smaller because I've got a 1/4 scale factor. All I do is take all the points. So we'll start with P. This point P is at -4, -4. And all I'm going to do is times both of those. I'm going to times -4 by my scale factor. And when I do that, I get -1. So this point is now going to come at -1, 1, which would be right in there. So again, this point becomes -1, -1, because when I times 1/4 by both of those, it gives me that. So Q here is at -4, 4. So again, if I times -4 by 1/4, that gives me -1. If I times 4 by 1/4, that just gives me +1. So that point will be here at -1, 1, right there. If I got this point 8, this point is at 8, 0. Again, when I times 8 by 1/4, that is going to give me 2. And then when I times 0, it just gives me 0. So this point becomes 2, 0 at that point in time. So it's going to become right there. And then this point that is at 8, 8. Again, I'm going to times those together, and that'll give me at 2, 2 is what that'll give to me. So I go right up Yasso. And then I can just create these lines here. And that's what our shape would look like. And I can do that with any of these here. So if I go to the one all the way to the right here, I'm timesing everything by 2 at this point in time. And my center of dilation is at 0, 0 for all of these. So when I times this by 2, this point that here is at 1 or -1. Again, we've got a point at -1, -1. If I times both those, that'll become, if I times these by 2, it becomes -2, -2. So this point would then become right down here. If I times the B, which is at 1, 1, again, I have 1, 1, that's going to turn into 2, 2. So we're going to go to 2 and 2. This point that's at -1, 4, again, -1, 4. If I times that by 2, that'll become -2, 8. So this becomes -2, and then all the way down here to -8. And then this point that's at 1, -4 will become at 2, -8. And then, again, we can just draw this shape as best you can that way. So that's what that would look like. Okay? You should be able to do these last few. Let's look at these. So point T is a vertex of a triangle. So that point T is a vertex. Point M is the image of T, that should say of T, after the dilation. So M is after the dilation of T. Find the scale factor. So it already gives you the point. Again, it's just new divided by old. So my new is M, my old is T, and I can pick either X or Y because neither one of these are zeros. So I can go 2 over 1, or I can go 10 over 5, which again, that's just going to simplify to 2. Okay, again, same thing here. I can go either X or Y. So if I take my X's, new would be 2, old would be 4, and that simplifies to 1 over 2. Okay, let's do the Y's here. So this would be negative 30 and negative 6. So new over old, so negative 30 over negative 6, and that's going to simplify to 5. So that's how you find those scale factors for that. And then these bottom ones want you to use your center of dilation at 0, 0. It has a line segment P to T, so this line segment 1, 1 to 3, 3. Use the scale factor to write the ordered pairs after the dilation. So we've got 2 dilations on this. I've got K is 2, and then also K is 5 up here. This is formatted just weird. So this top one, we'll just look at number 4, which is just this part right here. So I have this line segment P at 1, 1. When I dilate it, it'll become P prime. I'm going to times it by 2, it will become 2, 2. And then I've got T at 3, 3. When I dilate it or times it by 2, because that's what my scale factor is here, is going to become T prime, which will give me 6, 6. And so I will have this original line segment that is here at 1, 1 and 3, 3. So there's my original. And then my new one, which again is these two, will become at 2, 2 and 2, 3, 4, 5, 6. So that new one will become that red line now. Okay? And it just makes that grow. And that center dilation keeps it on the same path. If we change the center dilation, we do something different with that. But we would, again, that's for a later unit. So find scale factors, be able to apply them, and go that way. Okay? I'll leave these last couple, and you can check the key for those as well. So, all right, we'll see you later. Bye.